Hello everyone, I'm Xiao Gang. Okay, let's still look at this document because it's very important. Very important. I'm telling you this because if you don't understand this, you won't understand a whole series of things later, like GS, right? And our GameCube, these things, and also some game phase divisions. Let's look at this 5.0. Note that our version is 5.0. You'll find that 5.4 doesn't have it. 5.4 doesn't have this thing. So I read it. I often read the official documentation, including 4.2, 7, 5.0, 5.3, 5.1, 5.2. I often look at them, so I know there are some documentation changes. So what is a GAMPO tag? It's marked, translated as tag. It is a conceptual hierarchical label. It can be arbitrarily layered. It is layered using docs. For example, like this level. Then this first level, second level, third level. It's like our world's first level menu. Second level menu, third level menu. You understand what I mean, right? Family means family. This G is eating. I don't know what this is either. Hello class. What is this? This is a type of person. Just ignore this. That is to say, these two are the broadest first level menu. Then this space is 2. This space has the most specific third level, specific to a certain object. And this menu is actually, if it is such a gameplay tag, it actually includes these two. That is, they are also included. That is, if you filter by family, then this gameplay tag, it satisfies the fam. Then if you filter by family eating, then this gameplay tag is also satisfied. If you satisfy it with this method, then only it got filtering in this way. Then only it is satisfied. Then what is a gameplay tag? And what is a gameplay container? Gameplay tag. It is just. This is called a gameplay tag. But now I have a container. If I have a tier array of lamb now, then it is called a container. It is a container. Then you can create multiple such tags. So this marker and this marker container are essentially the difference between one and many. That is the difference between single and multiple. In the single case, it is conceptually divided into. So in the single case, how many dots we have corresponds to how many levels there are. So obviously, this is one with 3 level 1, level 2, level 3. So here we make a distinction between single and multiple for simple usage. Right, then just like here, actually look at this actor right here. It has tags and one of them is called tag. So corresponding to our gameplay tag. This is called a container and this is just a plain tag. Oh, so no problem. Good. Let's collapse this part here. Actually, don't collapse it. We'll just open another map for it later. Okay, let's open another map for it first. Okay, then we give it an L, gameplay tag. Okay, good. Let's save here. Okay, before we create it, let me show you first. Since this is a beginner tutorial after all, you might have never been exposed to this before. So here, open our level blueprint. We will create 2 new variables here. We can type here gameplay tag and then here we type gameplay container. That's it. Then we add my tag and we'll call it my tags. Okay, now let's compile it. Let's take a look. You can see here it doesn't have a tag yet, right? Actually, it still doesn't have a tag. And here you can actually add multiple tags. So here, let's just add one for now. We'll add it here. Since it's for display, we'll give it just it's a still sweeping tag. Then it's used for our shell and we consider it show my tag. Okay, we won't add the node count. The node count is just a temporary demo label. Then we add 6. Here we need to select the source. Let's see how to do this. Adding it this way might not work. Let's write it again. This part hasn't been written. Let's put it in the default game tag. In I, same as before. 移岗, then show. Let's call it my tagier. My tajiru. Okay. I clicked the wrong spot here again. It's already there. Then it is what it is. You can see you can only select one. Then let's pay close attention. Let's go to our config. We haven't looked at this file before, have we? Let's take a look now. You'll notice there's a tag here, right? Very important. Next, right here, this is a tag. Then my tag dies. It is quite special. You can select the tag. Then we add another one. We need to give this a tegra. Okay, we still add it here. This is the container, right? This is a simple concept of single and multiple. Then we can match based on the hierarchy concept and perform a match. We'll talk about matching later. Now let's continue with the following content. This way you have an intuitive concept. You can drag it out. It looks like this. Okay, next let's come back here and take a look. How do you create a tag? Actually, there are many ways, not limited to this one, especially after voice and game feature. Anyway, as long as you have created it, you can manually add or remove it. In our project 3.0, so where is this? It is actually here. Take a look. Project 13 GameplayTags. It has this place. This way, you can do a management. This didn't exist before. It only appeared after the new version. These are some tags for incremental input. This place shows the source of the tag. You see, this place comes from here. It's also obvious that you can add a new tag here. Right, let's add it here. This is adding a new source, not adding a new tag. You can add a new tag here. Then let's add it under. Scuffed under tag. We can do it like this. Add a subtag. This subtag is called a tag. So for this tag 1, we call it a tag. Okay, so that adds a tag. And its source is also at this location. No problem. Then the second method is you can create a new any file. You can see we add an any file like this. We put it here. We call it FGameplayTag.ini. Let's add it. Right, there it is. We can take a look here. Let's go back to our project. Then here, inside that, there's our project's config. It might not exist yet. Let's try to add a source here. We can see here, let's set it to small, and we can set this to 6. That is, we display another one called order tag. Okay, then you'll see its source is at this location. Then if we click to open it, let's look for it. It is already here. This is a new source. Then you can further construct it using data table resources. And this place, this is loaded by default. That means it will load the files we just saw. Then when you add a signature here, you can add a comment. This data table, we should have it below, right? Let's check below, because in our previous video, we demonstrated the data table. And this place is where you can download some comment codes. There are also some automatic import settings. Then in the ini file, you can actually manually edit it. You can see we can manually edit it. So we are still here. We'll manually paste one here. We'll call it 小刚2. We'll give it a handle. See, we manually, and then you'll notice the editor still hasn't updated. Let me check. We can take a look here. The area hasn't been updated because you notice there is a characteristic, which is the gameplay tag. It does not really support dynamically adding or doing anything like that, because after the game is packaged, it only has those tags. They are fixed as those tags. So you should try not to dynamically add or use them, as this can cause some problems. For example, if you suddenly dynamically generate a tag, but other clients do not have this thing, then it will not match. There will be some issues. So this tag, during our development, you just set it, and that's fine. Then we can hit can importer. You can see here we look, can we config here? Not this project. Here we re-import, see if it works. Okay, let's check again. Still not here. Then let's just restart the editor. That's no problem. Let it restart the editor. It's a bit slow on our end. I think we need to wait a moment. Yes, this part is saved manually. This is very useful. We can divide it. For example, if I work on 3C, and you work on the mail system, the backpack system, the inventory system, and so on, then we each use our own tags. We each manage our own. You don't touch mine, and I won't touch yours either. That's what it means. In other words, you can split it out. This place is quite useful. You see here, this handle comes in, no problem. Then this is a data table support. You can pay attention through this data table. For example, if you need some external. For example, we are a team A, team B, team C. They are all developing based on our 0 team, and we are developing 10 versions in parallel. As I mentioned before, the story of these 10 versions being developed in parallel, that is, our base version is the same. Then our 10 teams are each assigned 10 packages. Our 10 teams work together. First, prepare the packages that may or may not be included. Then, first release the packages that are included. Then we have a base package. In that base package, may have some tags. These tags can be managed and used through this kind of data table resource for storage and use. Then you can see it is here. It looks like this. It has a vehicle related tag table and this table. Note that we haven't covered art, tate. Actually, you should use it often in blueprints, so it should be fine, because this requires a foundation in blueprints. Even if you don't have very deep C++ skills, as long as you have a basic understanding of blueprint, this course will be quite easy for you to learn. Then we might need to create this table first. It's also very easy to create. We'll just follow a standard creation process. We'll put it here. We have a tetot. It should be under mask. In the miscellaneous category, there is a taton. Then we select a tag here. That's it. Then we call it DT. Because DTag 小岗 should be your game table tag. Okay. Then here we are. We go to add a tag. Then here, it has some tag names, or here. Then we just write it here. We'll just write something random here. We'll give it a magic water attribute tag. For example, this kind of water attribute tag. Water attribute tag. Then we give it a new one. The component in front. We can ignore it for now. There's nothing to say about this. We call it magic. Then we call it magic attack. I'm doing this for easier matching. Let's write another one. We call it magic. Magic fire. We call it fireball attack. Okay. This part is injection. Now we need to import it. Let's go directly to our projector 30. Let's go through this area. Then you can see there is one here. We can see it has been added. It should be that we add one. Let's take a look at this part. Hey, this magic is here. Actually, this part is done through data table. This management method is also quite good. Then there might be some issues like retargeting here. It might have been renamed, but you might not be able to change the previous ones or something. Okay, well, more or less. This management here is very simple. Delete from secret or see where there are references. No problem. You can see here. That is, if you remember you renamed it. You need to make some progress. Actually, it's the same as our redirection. That is, if you perform some rename operations, there might be some redirection issues you need to pay attention to. This is a minor issue. Then let's take a look at its editor. Actually, it still has certain limitations. And here is adding an authorization. Actually, this situation can occur in multi-person collaboration, as we mentioned earlier in the development guidelines. That is, you should not modify the project's basic text or some config IEI. Sci. If you move it, everyone has to move along with it. If you didn't make a mistake in the change, it's fine. Or if others didn't touch this file, if two people modify it at the same time, then there will be a conflict. So usually we will take these files and set up something like a restrictive constraint marking control. That is which users can modify it and which users don't need to modify it. Okay? After applying restricted control to it, you might not be able to delete it here. You'll find it's gone, right? So actually you can add it now, but you can force it to be removed from the ini file. Okay, good. These are all small bits of knowledge. The main point is to explain to everyone. This GameplayTag, how it is used and calculated. Let me show everyone how it is used and calculated. We will go through them one by one and explain. But before we explain, don't try to compare them side by side. Looking at them one by one will be very confusing. Actually, when we make games, work on engines and do our jobs, a lot of the time we start from a human perspective. We think this tag should be matched like this. So it is actually similar to the mathematical concept of open intervals and closed intervals. This kind of Boolean operation is intersection, right? Intersection or non-intersection cases. Let's just take a look. Obviously, if we have the tag A1, when we need to use match tag, if we match it with A, it will definitely match because A1 includes both A and A1. If we include 1 and we use exact matching, then it must be an exact match. Then it must be false because A and A1 are not a perfect match. Then this matching means that you input the tags here. As long as any one of them matches, then it succeeds. Obviously, A and A1 match. So why is it false here? Because it is an exact match again. So here A1 and these two things, they are not an exact match. And this is a MatchesAll. MatchesAll should mean that what is passed in must satisfy all of them. That is, it means all of them must be satisfied. That is to say, for example, here there is, for example, it is a 3-level called AE known to B. Then here you pass A. And also pass A, that is okay. So here you can pass multiple elements, all must be satisfied. This is all exact matching. That is, there cannot be this kind of conceptual satisfaction, so pay attention to this point. This all should refer to this. This means it can pass multiple elements. And here, it is obviously this place. This is a tag. This is a container. So does the container contain A? Yes, it does. Does it contain this exact A? Obviously, it does not contain the exact A, because it is A1, not B1. Then do A1 and B. One contain any AC? Apparently they do contain A. Then do A1 and B. One contain any exact A. AC, that definitely does not exist because it is exact. And if this is all, it means whether both A and B exist under this level. Obviously, they both exist. So for all of this to be accurate, obviously, this place is false. So note that all means that here, several of its elements need to be conceptually matched here. So conceptual matching, one type is exact matching, one type is inclusive matching. So this is why it looks so complicated, because it has two layers of concepts. One is conceptual matching, right, and the other is whether all these elements need to be fully matched, or just any match. So there are several levels of concepts here, okay? Let's take a look at this example. Look at this example. And here, there is a simple tip. That is, if you provide an empty or default one, then all will return false. Because obviously our tag is calculated based on existence. It won't have this absence marker, and it won't have this default marker. Then we can look at this blueprint operation, how it operates. We'll skip this text here and look directly at it. Obviously, here there is some begin play has a boolean. The boolean here requires simultaneous satisfaction of a press. So obviously in this place, this tag counts a location. Whether it has this test2 tag must match exactly, or whether it must have this task1 or task3. Only these two must have one that is true. So in this case, this position will be true, and this place also matches exactly. Okay, seems we cleared up a bit here. Sorry, let me pause and sort out this logic. Let me go over this logic again for everyone. Don't look at this paragraph for now. We should only look at the result of this tool. This is an AND. So, for this in your anti-tag, it means that if you pass in these two parameters, at least one must be present. That is, as long as you have either tests1 or tests x, then this part is fine. So these two conditions involve one being negated and one being an OR. Let's first look at this first one. It means as long as you have tests active, it's fine. This condition here means you must have both 1 and x, and this part is an OR. That is, as long as you satisfy one of them, it passes. And since it's a root, we want it to be true, then neither of these two can be satisfied. Let's go over this concept again, because this place must be true. Then this place must be false. If it is false, then both of them cannot be true. Then you cannot include the tag 2. You also cannot include both. Remember this sentence. Cannot include the tag 2. Also cannot include both tag 1 and tag 3. Then the condition for this place to be true is you cannot include text 2. Also cannot include both text 1 and text 3. Then the condition for this below to be true. It means you only need to include either text 1 or text 3. One of them is enough. Then the conclusion we draw is you only include text 1 and it can pass. Then you only include text 3. You can pass. You only include both text on and text 3. Sorry, cannot pass. You include text 2. Cannot pass. Okay, it's a bit confusing. Let me demonstrate again for everyone. This concept. Obviously, we need to add a tag first. Let's add it here. Here we This tag should be called test1. We need to specify it. We can place it here, just stone. Then we add it here. Test. We need to keep it so that everyone can match this thing. This thing. It is a bit convoluted, but this thing is very helpful. It's for when you later need to implement mutual exclusion. That is, mutual exclusion between skills. For example, doing beast machine, doing death, doing fuller, doing stiffness. That is, if I have the boss tag, I am immune to all stiffness tags. This thing is really easy to use. Okay, so we'll still go into the level blueprint. Simply write its logic. Then we'll give it a... I really think we need a container here. Tag container will make it convenient for everyone to run a test. GameplayTagContainer. Okay, then we'll just run this test inside gameplay. This code doesn't seem to work. If we paste it over, let's do it this way. Let's container. Okay, we take it over here. Obviously, this place is meant to back. I'll drag this over for you myself. Okay, first we make it check whether it has this tag. That is whether it has test tool. We use exact match. Okay, then next we go. Check whether it satisfies all of them at the same time. Right. All of the 1 and 3 items. Here, we should just create one. We can delete these two here. Then we select both 1 and 3 at the same time. Okay, after selecting it, we also need to use exact matching here. These two conditions are both not allowed by us. Neither condition is allowed to be satisfied. So there is a not operation here. Okay. So this condition means that if I want the final result to be true, then I cannot satisfy either of these two conditions. That is, I cannot include case 2, and I also cannot include one tax at the same time. But I still want it. I cannot include both at the same time. I can include only one of them or only the other, or include neither. If I wanted to include one of them, so here we can have MatchesAny tag. It is a bit convoluted. Then this lets us take a union for verification. Finally, we let it print this result. Then, this time, we give a B branch. Close such a branch. We give it this result, and we need to pass the verification. Verify spy. Okay, obviously, when we verify at this point, it definitely won't work. Because you can see verification failed. Because you have nothing right now, then this is true, but this one is false. So in the end, you are false. Then we give it a test 1. We can see test verification passed. The reason verification passed is because this one is satisfied, and these two are both false. Then here, it becomes true instead. No problem at all. We give it a test 3. You can see it failed. The reason for the failure is also clear. Obviously, this condition is true. Then this condition is true. Invert this condition. Then false. Then this triggers. It forces here. Then we do it this way. Keep only this test broken. You will find that, right, it passes the verification. This is actually the same principle as test 1 because this condition is met. Because I need to include breaking. But these two are not met. So this place is false. This place conversely becomes true. So this already satisfies the condition. Then, if we add a text 2, okay, we can see verification failed. The reason for the failure is simple. This place of yours is true. Then it becomes true. Conversely, it becomes false. Then this place is false. Then this place is false. Okay, so actually, this is just a simple demonstration. There is still a little bit of interference, I think. Okay, so this part is about reducing this kind of query. That is, reducing these parameters. We won't go into detail about this. And this part is, it uses this gameplay query to reproduce the test sample. You can see that writing it this way is actually very complicated. Very complicated because we had issues during the parsing earlier and we want to extract it into a generalized thing like this. Is it possible? Of course, it is possible. So we can use something called a gameplay tag here. Something like that. We can demonstrate it to everyone again. Same place again. We just need to move it a bit. Okay. How is it written? Actually, it uses this. That's container match tag. The QR storage function. That's container match QR. Such a storage function, and you can see here it passes a QR. Very similar to our usual. We still use this test, the corner container, and we copy this whole series at the same time. Okay, let's place. So here we mainly need to this tag. Weight, better promote it to a variable. We'll set it up in this aspect. Okay, then here you can see, here you can start writing the expression. So how do we write this expression? We can see it's written like this. First of all, we can add some comments. The comment means, let's copy this text over. Otherwise, typing this out would be too long. It should be this one. A bit long. Here you give a strict inclusion. It can pause if you include both or include both of these tags simultaneously or include the task tag, then there's a problem. Obviously, this expression has ID another one of these. So here, there's something called all exclamation math. When we click on it, it has an expression called expression. For this first selection, it selects earning tag, which is match. That is, you must have one tag that is satisfied. So obviously, we can add two tags like this. As long as either 1 or 3 has 1, we consider this expression to be successful. Next, we add 1. That is, all expressions must be successfully added. This part is a bit confusing again. Actually, this part is somewhat similar to the behavior trees. Sequence and selector. All expressions must succeed. This means it is ultimately an AND operation. It is an A and B operation. Then add the second expression here. The second expression means not. That is, you cannot satisfy this. That is, the expression below cannot be satisfied. So obviously, which ones cannot be satisfied? So if you include both 1 and 3 at the same time, then obviously this one cannot be satisfied. This thing right here cannot be satisfied. And at the same time, this place, it also cannot be satisfied. This place as well. Just add the tag. Then first hold down adding tag here. Then select text 2 here. So actually, after testing like this and it passes, our result should actually be consistent with what we have here. Let's test it for everyone. And this container at this moment, obviously it does not pass. You see, this place passed verification. Let's check if we wrote something wrong somewhere. Let's look at this struct. It seems like something is missing. It seems like it wasn't saved just now. Let's write it again. Add one more. And here there is no expression to satisfy. Maybe it was missed just now. And if there is no expression here, it is actually 2. Add another one. And here is the selection or task match. That is the following. You cannot have both 1 and 3. And at the same time, you cannot have gap. This test. Okay, then this section actually corresponds to the section above. Let's click OK. Let's check again. Good. Alright, so it's saved now. Then let's create another one for everyone. Then we push here. Then all actually corresponds to this node. Then added tags index 0 corresponds to this node. Index C corresponds to this node. And this expression corresponds to this index. The last two, index 0 and index on, correspond to these two respectively. Right, okay. So actually, this should be easy for you to understand. Let's do it again. Verification failed. No problem at all. We can change this container somewhere. Let's set it to 3. You will see it passes verification. So this logic is actually exactly the same as what we talked about here. This is really impressive. Let me tell you, it's especially easy to compare. And actually, So how do you mount it? How to use it in CII? Diplant is very simple. Just mount it on the side like this. But you definitely want all seaters to have a unified interface or method entry point to do this. So that's what we're going to talk about in this lesson. So if it's used in a game, you can just add this tag or taggler container. If you want to link it in C++, actually, you can have an interface to implement a C++ implementation and then override the function in this interface. Then Blueprint can also access it through this function. But in some cases, you might have many containers. For example, I want a backpack container. I want a status container. I want a warehouse container. I want a mail container. I want a game state container. Put all of them into one tag container. If needed, you should separate them for use. It is very convenient in large projects. Then you just need to search across multiple containers. Okay, that's all for this session. We've talked for half an hour because it's really that important. You know me, so we spent half an hour just talking about this bunch of blueprints. Thank you, everyone.